Hello, I'm Blake Simon, and this is Sports Science. Today we're going to be talking about the physics of sports, looking specifically at the kinematics. Now let's first check in with our first athlete, Aman Sharma.
Here we have Aman Sharma, who was recently named the best quarterback from his local apartment complex. Let's see him show off some of his awesome skills. Now let's take a closer look at Aman's throw. As he rears back to throw the ball, when he releases it, the ball has a vertical velocity and a horizontal velocity. The vertical velocity is not constant because it is affected by gravity and is negatively accelerating. However, the horizontal velocity does not change, it is constant as long as there is minimal air resistance. You can see this in the ball's flight path. The displacement by the ball equals the velocity of the ball, the horizontal velocity of the ball, times the time it was in air. And you can see the displacement was about 30 yards. Now let's check in with stud baller Abhishek Ramani as he shoots a couple practice shots in the gym. Let's now re-examine the basketball's flight path in the air. Like the football, it has a horizontal velocity and a vertical velocity. Now I'm going to pause the ball at its highest point in the air. It reaches this point midway through its flight path, and the vertical velocity at this point is 0. There is still a negative acceleration due to gravity, but at this certain point, the vertical velocity is 0. Gavin McDaniel is one of the fastest football players for the Coppell Cowboys. He's also one of the quickest to accelerate. Let's take a look at him running and see how exactly he does. Gavin starts off with an initial velocity of 0, but then he begins accelerating as seen in this first frame. In the second frame, Gavin is running with a constant velocity, meaning that he is not accelerating or deaccelerating. In the final frame, we see Gavin slowing down, meaning he is deaccelerating, his acceleration is negative, and slowly he comes to a stop. If we wanted to find Gavin's displacement, we could use the following formula. The following formula can find you displacement, which is otherwise known as horizontal position, using the following variables. Solomon Thomas, number 90, is a defensive player for the Coppell Cowboys. As you can see by these highlight videos, he's pretty strong and he hits pretty hard. Let's take a closer look into one of his collisions. Solomon comes at Aman Sharma with a lot of momentum. When they collide, they continue together in motion, making this an inelastic collision. Because this is an inelastic collision, kinetic energy is not conserved. This is different from an elastic collision where kinetic energy is conserved. In both collisions, momentum is conserved. Because momentum is conserved, meaning there is no change in momentum, there is no impulse, because impulse requires a change in momentum. Momentum is velocity times mass. Let's see a couple of replays of that collision. Once again, I'd like to thank Aman Sharma for volunteering for that segment. It's time to do work and go to the weight room. Work is equal to the change in energy, or force times distance. Aman is using work here because he's using force to lift the weight at a certain distance. When Solomon lifts the bar has kinetic energy because it has a velocity. But the bar also has a potential energy because it is above the ground, and therefore gravity has a potential to act on it. The total energy of the bar is the kinetic energy plus the potential. Let's take a look at the energy of the bar at two specific points. At the first point, the bar is above Solomon, and the velocity is 0, meaning that the total energy is equal to the potential energy, which is mass times gravity times height. The kinetic energy is 0 at this point. At another point, Solomon is letting the bar drop to his body. At this point, there is a kinetic energy because there is a velocity. The kinetic energy is equal to 1/2 times the mass times the velocity squared. However, there is also a potential energy as well, but the potential energy is less because the height is less than the other point.
Well, now we're at the conclusion of our program. I sure hope you learn about sports, science, and kinematics. For Sports Science, I'm Blake Simon. See you next time.